Hello everyone, this is the video lecture for Pre-Calculus, Chapter 5.1, the unit circle. Let me actually show you what that looks like. It's right there. So the unit circle is something that basically you got to memorize. Now you might be thinking, like, looking at all this, there's no way I can memorize all this. And I understand. What I would say then is to focus on quadrant 1, all this stuff right here, okay? So focus on these guys. Technically, again, I'm saying that you've come from Algebra 1414, and I'm kind of halfway assuming from Central Texas College, you had a whole chapter devoted simply to all these degrees and radians and unit circle stuff and all that kind of stuff. So this might be a review. Maybe you've seen it before. Maybe it's kind of fuzzy. That's okay. So we're going to go through it. I'm just going to show you and I'm going to use it as we keep going. But again, I'm planning and I'm thinking, I'm going ahead, I'm visualizing the fact that we're going to have to memorize this. I mean, basically the whole thing eventually. But right now, just let's get started on quadrant 1. And what I'm going to do now is I'm going to just draw quadrant 1 on my own, kind of talk about it, and then we'll get into some homework problems, okay? So quadrant 1 of this big old unit circle, of course they got like this big old thing there. You can see that this is not as good as the actual unit circle paper. By the way, this here is a part of the formula book that should be on Blackboard. It's already there. And so it just, if you flip through it enough, eventually you'll find it. Okay, so first off, we have 0 degrees, which is kind of funny here, 0 degrees. Also, that would be 0 radians. We'll continue talking about degrees and radians as we keep going here. This one here, let's say it's 30 degrees, or that would be pi over 6 radians. 45 degrees. Again, I'm not perfect. I'm trying my hardest to make them perfectly straight here. 45 degrees, that is pi over 4 radians. By the way, if you're not copying this down, just because you think you got this guy, that's cool, but I recommend drawing it. It's kind of a memory tool. Like, humans memorize things better when you put your hand, drawing a pen on paper. It's better. You memorize stuff better whenever you're doing it yourself, I guess you can say. And then we got 90 degrees, and they say this is pi over 2 radians. Okay. Degrees are always from this 0, and we're going up to these here counterclockwise. But again, I'm kind of halfway assuming you got some of that. If not, just think degrees. Everyone's really, honestly, pretty good with degrees. So if I say this many degrees, I'm guessing you'll be okay with that. Radians, a little iffy. But let me go ahead and give you the points that are important. So points on this unit circle, this unit circle keeps going. Okay, but we're actually concerned about the circle, unit circle, so we're focused on the circle. Unit means distance 1. So basically this radius here every time is always radius 1. Okay, let me even write that up here. Radius, I'll write radius. Radius equals 1. Unit means 1. And so at the end points here, you'll be seeing, I guess you could say, like a XY coordinate on the unit circle at this radius equals 1 at each angle. And so this guy here is actually 1, 0. Again, this is an XY point. Right here, this is X equals 1, Y equals 0. Like here, tick mark. Here, let me keep going on this guy. Here's 2. Here's 2, 0 right over here. You see what I'm saying? This is a number line. This is just like a Cartesian graph, something that we've been graphing for ages, okay? So this is just a graph, 0, 1. And this guy up here is also pretty easy. He's, so 1, 0, and then 0, 1 over here. Again, X equals 0, and then this is Y equals 1. And if you keep going up, there's Y equals 2 up here. Down here, this is, negative Y and all that kind of stuff. These guys are going to be the ones that you're going to have to memorize. And there's tricks for it, so let me just go ahead and write up what I got, and then we'll go from there. This point here, my 30 degrees is kind of in the way. This here is square root 3 over 2, comma half, comma 1/2. Again, this is x and y, okay? So square root 3 over 2, and then 1/2. Now notice over here at the 60 degree mark is 1/2, comma, square root 3 over 2. What I'm getting at is these guys are symmetric. So they're just, they're inverses, I guess you can say. I'm switching my x and y around in order to get a different answer there. So if you can remember one, then you just flip it for the other one. It's not too bad. This guy here is square root 2 over 2, square root 2 over 2. Again, that's x and y. So notice that we have, if you can see the line here, we got a 1, a 2, and then a 3. And similarly this way, 1, 2, and then a 3. And this 1 here is kind of funny, right? 1/2. What if I did this, square root of 1 over 2? Wouldn't that just be a 1/2? So like it doesn't change if I went back and put a little square root on these guys. Maybe that helps you memorize it better, that literally everyone gets a square root. It's just that, the 1, it simplifies, so it's not a big deal. So everybody gets a square root in the top. Everybody gets a 2 in the bottom. So these are just memory tools, okay? However you want to do it. If you can get this down, if you can kind of remember this, then you're very much on your way to memorizing the whole entire unit circle. Because then it's just quadrants. You change your sign, negative, positive, whatever. So, and we'll be going through that more as we continue in this chapter. And so I don't want to bore you too much on this. I just wanted to kind of present it to you. What's kind of funny is that the very first questions here have nothing to do with this. So I'm going to go through the homework, and you're not going to use this at all right now. But we will use it eventually, just on the first 2 questions or so. It kind of just depends. In fact, the homework section that I have, my paperwork ready for this, very small. This will be very fast when we start doing the homework here together. So 51003. They give me a P, point P, 4/5, -3/5, and that they say is on the unit circle. Okay. Well, let me map this for you, if that's okay. I'm going to map this for you. Where is this colliding? Well, this is 1, 1, 1, 1. That's my unit circle there. Okay. Radius of 1. -3/5 for my y. So negative y, but a positive x. So positive x, negative y. My x is a little bit more than the y, so I'm going to think right around here. Now you're thinking, oh, wow, that's like, 330 degrees or something like that. No. There's no degrees associated with this stuff. I have no clue what the angle is. There is an angle. It's either like 47 somethings or 53. I don't know, something like that. Regardless, it doesn't matter. We're not talking about angles here. I'm just saying that this is a point on a unit circle. Okay, that's it. That's all I care about right now. So what is the question asking? So they say that, well, x squared plus y squared is equal to what? Well, generally this is r squared. But because it's unit circle, well, that's going to be 1 squared. And you can write that into WebAssign. It should be fine. The true answer they'll give you is 1. Obviously, 1 squared is just a 1. You don't have to simplify in WebAssign. But then what would that look like if I were to write that stuff out? So x squared, y squared is equal to, and they got box squared plus, box squared. Well, we know what our x is. If you go back up here, we got x and y. So 4/5, -3/5. They want you to simplify. I mean, this is kind of a little silly in my opinion. But they already did this part, but we need to do this one. Well, that's 16 over 25. And, oh my goodness, it results in a 1. Okay, so at the very, very end, they're saying this blank a unit circle. And it's one of those drop downs. So you either has is or is not a unit circle, and it is because it has a radius of 1, or I guess it's not is a unit circle, it is on a unit circle, but regardless, that's your answer. Click the is. Let's do another one. 51009. So I got P at point -5 over 13, comma, box. They say that this is in quadrant 3. Okay. and it's on the unit circle. So that's some information that we're going to have to take in here. First off, this is an x, this is a y. I'm trying to figure out what y is. Y is equal to what? Is there a formula? Well, actually there is. If you remember, x squared plus y squared equals r squared. This is just for circles in general. Unit circle means that my r is a 1. See, that's unit circle, okay? And that's just simply a 1. I want to solve for y. Y equals what? Well, I'm going to minus x squared on both sides. So got y squared is equal to 1 minus x squared, square root. Remember that you always have a plus and minus whenever you square root both sides, and this is equally important here. Okay, so I have a formula for it. Well, I have an x value. I can actually take that and plug it in right there. So, and so plus and minus. Again, I don't know which one it is right now. We'll talk about that here in a second. Make sure to keep this in parentheses. That's not two negatives make a positive or something like that. No, 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 no. These two negatives are going to cancel to make a positive here, and then we still have another minus sign. Retain those parentheses, very important. So I got a positive 25 over 13. Again, we're subtracting the... No, not 13. 13 squared is, what, 169? Is that what it is? I don't know. I did all this in the calculator. Here, let me just verify. 13 squared is 169. I got it right. Okay. So 1 minus 25 over 169 is a decimal, of course, so I do the math to frac. I did not take all these steps on my paper. You could just skip ahead. I probably should have just done that instead. The square root of each of these separated should make 12 over 13. Now let's pause on this. We got our y values, but now it's got to be one or the other. It can't be both. It can't be both. So I got to choose one or the other. Is it negative or is it positive? Well, notice that we're talking about quadrant 3. Quadrant 3 is like down here. This is quadrant 3. So I'm going to ask you, is y bigger than 0? Or is y less than 0? Is it a positive or a negative y values? Indeed, it's a negative. Down here, down, negative. So I'm saying I got negative y values down here in quadrant 3. So my answer, my final answer, has got to be a negative 12 over 13. There we go. All right. So that was it. Next question. 51021. So this is actually using the unit circle a little bit more. I cannot remember the exact what it looks like, but I got this guy drawn. So we're talking like 45 degrees and all that kind of stuff everywhere. They list out t equals 0, t equals pi over 4, t equals pi over 2, and keeps going. What I'm thinking is that they want points for each one of these, an xy point for each angle. So these t's are technically thetas, angles, and they're wanting the point, xy point here. So this is going to be x comma y. This is super easy. We're talking unit circle here. So I go over to my unit circle. I'm looking for 0 radians. And so I can see right here, these are the radian values. You can see they're kind of near the edge. So 0 radians. I just want to put that point in for the answer. 1 comma 0. That was super easy. What about this guy here? So now we got pi over 4. Pi over 4. There's my answer right there. Square root 2 over 2. Square root 2 over 2, comma, square root 2 over 2. Okay, keep cruising. Pi over 2 right here. What's my point? 0, 1. There we go. Like, that's it. And then you can just keep on going. If they give you any kind of angle, you can go, and it's on the unit circle there. You can just put that point in there. Cool. Next, 51027. So they're saying that t, my theta, and I'm saying the word theta, by the way. It's theta. We're going to be using that later, I'm sure. I don't know why they're using t in particular here, but that's fine. T, theta, whatever. That just means angle. It just means angle. So t in this particular problem is negative pi over 6. And they're wanting to know what that point is. I mean, it's basically just the question we did a second ago. Well, I want to know where that is on the unit circle. Negative pi over 6. Well, let's go look in here. It's not here. I mean, I got a pi over 6 here, but I don't have a negative. Well, think about it in degrees for a minute. We're talking 30 degrees, right? And so normally we have the positive 30 degrees this way, but this was negative. And so it's going clockwise now. It's actually my final answer here. Negative 30 degrees, or again, negative pi over 6. It's down here. So if I were to go down 30 degrees on my unit circle, what would I get? So I'm starting right here, 0, and I'm going down 30 degrees. Well, I would get, instead of 360, I got 330. You can see how I subtracted 30 there. And there's my point right there. Square root 3 over 2, comma, negative 1/2. Square root 3 over 2, comma, negative 1/2. Okay, that was it. That's literally all I do. So next question, 51030. I got t is equal to 4 pi over 3. What's the point? Where is it on the unit circle? This one's easy. 4 pi over 3 is right there on my unit circle. So just copy down this guy here. Negative 1/2, comma, negative square root 3 over 2. Okay, that was it. That's the entire problem. I guess if you're taking notes, it'd be cool to have like a little thing here and says, look, it's down here. I often convert these guys into degrees in my mind, and so you can see it's at 240 degrees. And degrees are just easier for all of us to think. I mean, I'm sure that you think, degrees to some degree. Haha. But it's important in my mind to know the degrees because we're all familiar with that. So in my mind, I'm converting this over to 240 degrees, and then I can go and do that. And I'm doing that in my mind, not just using this unit circle, because again, I'm telling you that you're going to have to memorize it at some point. I'm doing that from my memories. I already know this whole unit circle. Again, I've been doing it for a few years, but the idea is that I don't use radians so much. I use degrees because that's kind of familiar. Okay. So last problem I have in this section, they're wanting to know the reference number. I don't know why I have number. I don't like that. Reference angle. I think that's a lot better. Reference angle. Don't know why I wrote number. Maybe they have number. I don't know. So part A says t is equal to 4 pi over 3, which is funny because we just had that. They want to know what that reference angle is for that. What do they mean by reference angle? So let's say that I got some kind of angle right here. And that would be, 315 degrees, let's say. So then the remainder to get back to the x-axis would be a 45 degree to get there. Not necessarily a full circle. I'm saying to get back to the x-axis. Okay, let's do another one. I'm just doing one on the side here. Let's say I got, 120 degrees, something like that. And again, this is my angle here. The quickest way to get back to my x-axis is this way, right here, which would make a 60 degrees to get back to, and that would make that 180 over there, obviously. Okay, one last one. Let's say that I got an angle over here, okay? And so this is, I'm just going to make this up, 210. And so the quickest way to get back to the x-axis is actually backwards. So that would be like 30 degrees to get back. Not negative 30, just 30. They want the absolute value there. So let me give you, I guess, my Chad definition. My name's Chad. Hello. My Chad definition of this is the acute angle with, not with an E there, with the x-axis. Okay, I guess that's good enough. Acute means between 0 and 90. I guess I can use a t here to be more proper. Okay. Acute means between 0 and 90. And I'm just trying to make it back to the x-axis. I can go backwards, I can go forwards, I can do whatever needs to happen. So let me go back to the 4 pi over 3 in particular. We're talking about this guy. He's at 240. To get back to the x-axis, the quickest way, the acute angle there, would be this bigger amount, I guess. That'd be 60 degrees. That's 60 degrees. Okay. So I want to just say, well, 60 degrees. But they're not going to accept that, obviously. What is 60 degrees in radian mode is pi over 3 radians. Okay. Let's do part B here. I got t is equal to negative 7 pi over 6. Find the reference angle. That's just my own notation. Nobody else uses that. Where is negative 7 pi over 6? Well, let's go back to unit circle. 7 pi over 6 is right there. But now that's a positive, not a negative. Notice that it's basically the angle of 210. If I were to go negative, though, I start here at 0 and go clockwise. Aren't I going to end up right here? 150, basically. So, like, how am I supposed to rewrite that stuff? Well, just don't right now. Again, we saw that the positive is over here, but I don't want that. I want the negative, so I'm going this way now, and it's going to end up over here. Okay? I guess it ends up at 150 degrees. I don't really care about that either. I want the acute angle with the x-axis. And that's going to be only 30 degrees there. So what, 30 degrees, we're good? No, need a radian, of course. 30 degrees is pi over 6. How do I know those? Well, I simply go back here. I say, oh, it got 30 degrees. Oh, yeah, that's pi over 6. You could use it for that, too, I guess. Kind of like a formula conversion stuff. So the last one that I'm going to do, I guess I think I did part A, and this is part C, technically, but that doesn't really matter. Part D, it has t is equal to 3.5. Find the reference angle. This is strange. Like, what are we talking about here? Well, 3.5 radians. Okay, now let's go back to our understanding here. When I got pi, that's 3.14. 3.14. I'm talking about 3.5. So we're somewhere over here in quadrant 3. Okay, so like, let me just draw the best thing I got. This is 3.14. This over here is 6.28. That's a full circle's 6.28. It's somewhere down here. I don't know where. It could be at 30. It could be at 20 degrees. It could be at 43 degrees. I don't know. I'm not really caring about the degrees. It's just down here somewhere, okay? So my guess then is quadrant 3. Quadrant 3. That's going to be important to you here in just a second. So how do I find the reference angle? Well, it's going to be this amount right here. That little small area there. So why don't I take the 3.5 and subtract the 3.14, and that would give me my acute angle. And that is correct. That's how we do it. I say 3.5 all the way to 3.5. And I'm going to subtract, I'm going to go backwards the 3.14 to get this smaller amount here. It's like a difference. There you go. I'm going to subtract the 3.14 to get that little difference in between there. Difference. Well, this is not going to work because pi is not 3.14, 3.14159, blah, 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 blah. I mean, it keeps going forever. You can't do that. So instead, this is actually what you're going to type, 3.5 minus pi. Just like that. There's your answer. I have this cool little chart here that might help you. Some people like formulas. Some people like pictures. This kind of does both. So this is for reference angle, okay? It's kind of like a chart, kind of like a picture, kind of like a formula. If you end up here in quadrant 1, your answer is simply theta. Okay, so if they say, find the reference angle for 30 degrees, it's 30 degrees. You're done. There's nothing else to talk about here. Okay, when you're here in quadrant 2, the formula is pi minus theta. Or again, that would be 180 minus theta. I use theta, t, whatever you want to call it. Just angle. Okay, so there's your formula over there. So again, let's say I got 150, and they want the reference angle. I'm going to say this is my reference angles here. I'm going to say the 180 minus the 150 to make that 30 degrees. Notice it's acute, so it works. Quadrant 3, the formula now is theta minus pi, or again, theta minus the 180. And that's the one we just used here a second ago. See, notice my angle, minus pi. Let's do the 200, let's do 225 actually, just to kind of change it up. I don't want to keep getting 30 degrees all the time. So I'm going to then say 225 minus the 180, and I sure hope that ends up in a 45. See how these are all acute. Last one, quadrant 4. What's the formula? It's 2 pi minus theta, or again 360 this time, minus the theta. Last one, let's do 300. What's the reference angle? Well, 360 minus 300 would make the 60 degrees. Again, that's acute. Okay, that's actually all I have for this section. We'll be utilizing this as we keep going and relearning a lot of stuff as well. So thank you very much. Have a great day.